Okay, thank you, Barbara. Okay, so I'm at NASA headquarters, currently detailed to work in HEOMD in the Advanced Exploration Systems Division as the Chief Exploration Scientist. So my job is to make sure that science finds a place as the human exploration architecture develops. Just to remind everyone how we ended up where we are right now, kind of our big driver for us is SPD1, Learn, Lead and Innovate, and Sustainable Program of Exploration and Commercial and International Partners. With the key down here, whoops. So how does this work? I've seen everyone struggling with this thing. There we go. All right. The United States will lead the return of humans to the moon for long-term exploration, followed by human missions to Mars and other destinations. So that's kind of what's driving us at the moment. So to summarize that, we really are talking about a long-term strategy here that includes sending humans back to the surface of the moon by 2024 as preparation to lead forward to Mars. Okay, so we want to make sure we always kind of keep that in place and remember that. One of the important aspects to this is that by going back to the moon in a sustainable manner, it's going to afford us with plenty of science opportunities to collect data on the lunar surface in lunar orbit as we are preparing to move forward. So as Victoria said earlier this morning, I have some slides with lots of words. I'm not going to stress over the words. They're in the slide deck, and you can look at them if you would like to. But I'll just try to talk the story through here. In order to get us back to the lunar surface, we are developing what we're calling the Artemis Program. And so here's a quick overview of where that term comes from. And yes, I am aware that an Artemis mission has already gone to the moon, but this is the Artemis Program, which will involve multiple missions to the lunar orbit and surface. So Artemis is twin sister of Apollo and goddess of the moon in Greek mythology. So the Artemis astronauts will be landing and setting foot where no humans have been before at the lunar South Pole. This with the horizon goal, again, of sending humans on to Mars, so learning how to move forward. So we'll lay out a few definitions quickly so that everyone understands the terminology. We have the common lexicon as we move forward. We're discussing what we're calling Phase 1 and Phase 2 of the Artemis program. And so that can be a little confusing as to what exactly that means. So Phase 1 is basically the work we're doing now to enable that first landing on the lunar South Polar region by 2024. This will in some ways require development of unique technologies to meet that ambitious goal. Some of that will be able to be the baseline that evolves into supporting the sustainable presence on the lunar surface, which we're calling Phase 2, and we hope to have in place by about 2028. So that way you can kind of understand what we're talking about when we refer to Phase 1 and Phase 2. So this is a chart that we call the swoosh chart, and we like to show this one. It's a pretty good graphical explanation of what we're talking about. And I think a really important point to take away from this slide, as you're quickly reading it over my shoulders, is that really we're talking about strong collaboration between the Science Mission Directorate, Space Technology Mission Directorate, and our Mission Directorate, Human Exploration Operations. On this chart, if you look at the top where the swoosh name comes from, we're talking about the orbital assets that eventually lead to the landing on the lunar South Polar region. You can also see at the bottom the lunar surface, which before we get to the right side of the chart with the humans on the ground, we are talking about deploying robotic assets as well. Much of that falls into the bin of SMD, and I don't want to steal any of Steve's thunder, so I'm not going to stress over that. An important point to take away from this, though, many of us have heard the phrase EM1, EM2, missions that we were going to be sending forward. We're now replacing those terms with Artemis 1, Artemis 2, Artemis 3. So Artemis 1 is going to be the test flight of the Orion system into lunar orbit without humans. So this is the test flight of the Orion. Artemis 2 will be a test flight that has the humans on board, but does not have anywhere to go to at that point. So it will be in an orbit around the moon and return the humans back. After that, we'll be sending up the first element of the gateway, the power and propulsion element. So both of those missions will happen in 2022. After that is in place, we can begin adding to that to build up the gateway. So we'll have the addition of a pressurized module that will be able to support humans at the gateway. And then we will begin to deliver the pieces of the human landing system that will dock and aggregate at the gateway, enabling, by 2024, the human landing on the surface. Now, I mentioned the human landing system. I just want to briefly give you the overview on that. This is the notional NASA study of the way we believe the landing system to work. It's a 3-element landing system, including a transfer element, a descent element, and an ascent element. So I mentioned on the prior slide that these elements will be delivered by, they will be delivered by independent launches to the gateway, where they will aggregate as the human landing system. When the crew are delivered to the gateway on board Orion, 2 of those crew members will enter into the human landing system, and 2 will remain on the gateway. Those 2 that enter the human landing system will then be moved to low lunar orbit by the transfer element. They will descend to the surface after departing from the transfer element using the rocket on the descent element. They will conduct surface activities, and then they will return to the gateway on the ascent element. So this is our 3-element concept study. We are also going to be competing this. You may have heard the term Appendix H at some point. This is a broad agency announcement. We are now requesting that a single commercial partner provide these 3 elements to make up a commercial human landing system. That announcement, Appendix H, went out on Friday in draft form, and the potential competitors will have a chance to comment on that. We actually just held our industry day today where they could ask initial questions. So at the moment, Appendix H is basically out for draft review by the partners, and we expect those comments back, and we hope to have a completed draft within the next month to 2 months. This is just another way to look at what we talk about as Phase 1 and Phase 2. So again, Phase 1 is the landing in 2024. This will be 2 crew members to the surface using an initial capability suit. So this suit will not be the suit that we continue to use during a sustainable phase in the future. It will enable the 2024 landing and be the baseline concept that helps us evolve to a sustainable suit. In Phase 1, this is really a U.S. endeavor with our commercial partners. We anticipate some partnership with our international partners, but as we evolve into a sustainable presence on the lunar surface, we really are going to be depending on commercial and international partnership. And this is how we design this sustainable and flexible, agile approach to having people on the surface. Access, again, to the South Pole. Eventually, we expect that to be a broader access on the lunar surface as we develop a sustainable and possibly reusable human landing system. The gateway is a key part to this. It will be in a lunar orbit. Again, we have the gateway itself, a power and propulsion element, a habitation module, and a logistics module. Part of my job as a scientist looking at these elements is to think about how we can add science to some of these parts. One interesting aspect to this is that the logistics module, which is the lower part on that picture, it's going to be going up to the gateway per crewed mission to support the crew that are on board, bringing supplies and water, things like that. That will then depart from the gateway, and we say jettison into heliocentric orbit. So as a scientist in HEO who works on these things, I love the word jettison because it means it might be something that I can use. So we're talking about how can we outfit that with instruments, sensors. If it's going out the heliocentric orbit, that could potentially be a heliocentric or a helio study. So this is kind of the way I look at this architecture, and I'm trying to find ways to infuse science into it that might not be in the baseline. We did select a vendor for the power propulsion element. It's Maxar Technologies. I'm not going to go through all these details, but again, I want to put out the slide so that it can be looked at in the future. But this is going to be the element that supports the gateway. in this near rectilinear halo orbit. This is an orbit that is very easy to maintain. It also carries the Gateway out to about 70,000 kilometers away from the lunar surface. This is kind of the backbone that enables us to begin studying how to survive in deep space, enable us to get to Mars, while also supporting landing humans on the surface of the moon. So this is a slide that, again, has come from our SMD partners, and I, again, don't want to steal any of Steve's thunder. The main thing I want to take away from this slide is that as we lead to 2024 humans on the surface, we'll be conducting science. Some of that science is going to be critical to helping us make the choices we need to make about what humans are doing and where they're going. So this really is a partnership between the directorates. We're starting to think about where we might want to start putting assets on the surface. David Kring showed this earlier this morning. There's some white circles over there that are highlighting some of the areas with the most light that we expect to see on the surface, in some cases above 80% of the time in light. Those are better thermal conditions for our systems, as well as giving us a power source. So we're viewing that as a resource on the lunar surface. But there's a lot of other aspects to consider. We need probably direct Earth communications. The Gateway orbit has a blackout period with the South Pole of about 1 day per 6.5-day orbit. So we want to make sure we time these landings so that they can see back to Earth or find other ways to support communications. So there's a number of other aspects to think about. Moving forward into phase 2 and thinking a little bit about the sustainable presence on the moon, preparing for Mars, we expect to have a human launch per year after 2024. The human launch will be supported with a logistics module delivery to the Gateway each time, we believe. And again, we will continue exploring on the surface of the moon as we do so, eventually leading up to an ability to deliver 4 astronauts to the lunar surface. And that is where we stand as of today with respect to the Artemis program. And Steve is following me, Steve Clark, to discuss things from the Science Mission Directorate perspective.
Yeah, we have questions. I'm sure we have questions.
Try to use all my time so I could run away. Steve won't. He's not even getting out of his chair.
I have a question that's been bugging me for a while. How are you going to, in the Lunar Gateway, how are you going to protect astronauts from solar events?
Yeah, that's a great question. And those are things that we're going to have to deal with right now. So, there are different strategies. We may try to use water as a way to protect them, but we're going to have to think about that. We also have to think about how do we monitor space weather so that we know how much time we have to prepare, and how we can begin to predict what the impact is going to be on the Gateway at the time those events get there. I'm not trying to kid you and think that we have all this figured out, and this is why we're depending on the commercial partners and the international partners to help us get this figured out, as well as, and that was the point of my one slide with the science, we need the SMD science between now and 2024 to help us understand how to do this successfully.
Hi, Jack. I have a related question. I keep wondering, why do they keep showing habitats on the surface? Makes more sense to dig under the surface so that they would be protected from radiation.
Yeah, and I will give you almost the same answer that I just gave, in that we're still studying the architectures. We don't know exactly how we're going to do that. We don't know if we're going to have stationary habitats or if we're going to be building habitats that rove, and how we'll protect them from solar events, as the prior question asked. So I think don't read too much into the cartoons that we have here, meaning that that is a solid commitment to an architecture that looks exactly like that.
And a second question. How much of this is funded by Congress?
It's a great question. As of now, we put a budget request forward, and that's being discussed, and our position is not to discuss what's happening at the congressional level. That they'll figure that out.
This may be a question for you or for Steve. I'm not sure which one. But you mentioned the first module to go up for the Gateway. And went very quickly through the slides, and I know part of that module is supposed to have communication and communication capabilities so that it provides access to a large part of the moon that we don't have access to right now. So I want to know whether within the plans that module is intended to be available so that the smaller missions that are being planned now can have access to the lunar surface, particularly on the far side.
Yeah, absolutely important point to bring up. So the design, another reason that that orbit, near rectilinear halo orbit, is so important is that it does give us access from a comm perspective to the far side. So it could be used for telerobotic operation, communications. We also have to be very aware, Jack talked this morning about the quiet side of the moon, the quiet cone. That's a resource that needs to be protected as well. So we need to understand how to enable what you're talking about while preserving what folks like Jack and that community talk about. But the plan is that that orbit is selected in part so that we can communicate with the far side, and we are discussing what communications assets will be on the PPE in order to do so.
So you mentioned there will be one flight per your one-man flight, but unlike Apollo, this will be to the same location. Is that correct?
The current strategy is that we will be building up assets around the South Polar region. So I don't want to say that there's any commitment right now to landing at the exact same location. And we're working with SMD to determine how we use robotic assets in combination with human landings to try and make sure we do the best science that we can, as well as build up and preserve that sustainable presence through commercial and international partnerships.
So that leads to the second part of my question. So you all have assets kind of geographically clustered. Is there any possibility of, say, a robotic shuttle going back and forth from there to the Deep Space Gateway, maybe bringing back and forth materials and things like that?
Yeah, so we had a Gateway Science Workshop about 1.5 years ago, and there were a number of abstracts that brought up that topic as an option. We don't currently have a plan for that specifically, but ultimately the human landing system is intended to evolve into a reusable asset so that we would be refueling that at the Gateway. So presumably that spacecraft will be moving from the lunar surface back to the Gateway and has a capability to deliver some mass from the lunar surface.
Okay, and the frequency would still be once a year, or are they thinking more frequently at that point?
That is currently what we're talking about is once per year. But again, partnerships are key here, so we don't, we can plan for what we're thinking right now, but this is where the partnerships come into play. You also have the SMD contributions that maybe evolve in that direction as well.
Thank you.
Yes, thank you for your presentation. I was wondering how tightly defined or loosely defined South Pole region is at this point. Are we talking 70 degrees, 80 degrees? Where is that focused, or is it still TBD?
I would say TBD. I like to ask that question myself. I don't have a firm answer yet. You saw from the one slide we showed kind of the areas we're looking at that have access to the high light. Remember, we're considering light to be a primary resource. If you listen to any comments from the Space Council, they comment on that.
Because there's the orbital mechanics of getting in and out of there are far from trivial, and that's a big trade-off cost there.
Yep.
Okay, thank you.
Hi, Jake. Pascal Lee, SETI Institute. I was actually going to ask you how firm the South Polar region is even in this architecture, or is that even up for negotiation? Like the North Polar regions are actually topographically a lot more welcoming, and they have areas of permanent sunlight as well.
So for the human landing system, I've been curious about that myself. We are told we're landing at the South Pole. Now, I want to point once more to the slide I showed that talks about this being a collaborative effort with SMD. SMD has capabilities that can go to many locations on the lunar surface right now.
Right.
And Steve will be talking next, but currently the first CLIPS missions are not going to the South Pole.
Right. Okay.
Al Tadros from Maxar. I guess you talked about science being done from PPE and other elements of the gateway. Can you talk a little bit about the method for selecting and incorporating the science payloads on PPE and other elements of the gateway, either before launch or after launch once it's at NRHO?
That discussion I would characterize as being in its infancy right now. We are having discussions about how to develop that strategy, which will likely include participation from our international partners. And we do not have that well defined just yet. So we're trying to figure out exactly what the options are that we will have for loading payloads external of the elements that make up the gateway, as well as internal when the two crew members are there, or potentially operating independent of crew when the crew are gone. We are definitely discussing that, but I can't comment much farther on that.
All right, Jake. Thank you, Raptor.
Thank you.